When we talk about population density, it sounds pretty straightforward, right? You just figure out how many people are in a given space. But what if I told you the way we measure it can tell completely different stories about a country? Stories about its resources, its pressures, and maybe even its future. So let's dive in.
So let me ask you, how would you actually measure how crowded a country is? I mean, the first thing that probably pops into your head is just dividing the number of people by the size of the country. But is that really the whole story?
Well, it turns out the answer is a lot more interesting than that. There isn't just one way to do it. Nope. There are actually three key ways, three different lenses we can use, and each one shows us something totally unique and really important.
Okay, so let's start with the one we're all familiar with. This is the most common, the most basic measure, what we call arithmetic density.
This is pretty much population density 101. You take the total population of a country and you divide it by the country's total land area. That's it. This gives you that classic people per square kilometer number you see all the time. The formula couldn't be simpler. Total people divided by total land. But, and this is a big but, this super simple average has a major blind spot. And here is the big catch. This method can be incredibly misleading because it just assumes people are spread out evenly across a country. Think about Egypt, for example. It's a huge country, so its arithmetic density doesn't look all that high on paper. But we all know that most Egyptians live crammed together right along the Nile River, while massive parts of the country are just empty desert. So that number, it doesn't capture the real-life feeling of being crowded at all. So that gets you thinking, right? What if we tweaked the calculation? What if, instead of looking at all the land, we only counted the land we can actually use to grow food and support everybody?
And that question leads us right to our second lens, physiological density. And trust me, this is where we start to see where the real pressure is.
Okay, so physiological density totally changes the game. Instead of dividing the population by the total land, we divide it by the arable land. The land that's actually suitable for farming. All of a sudden, we're not just measuring how much space people have, we're measuring the pressure that a population puts on its ability to feed itself. This number is a huge deal when it comes to a country's food security.
So the formula just shifts a little bit. Total people divided by arable land area. It seems like a small change, but it has a massive impact on the story we're telling.
Just look at this contrast right here between Bangladesh and Australia. Bangladesh has a massive population living on a relatively small amount of farmable land, which gives it an extremely high physiological density. Then you have Australia, with a way smaller population and vast farmlands, giving it a very low one. This tells you so much more about food security and resource strain, a story that arithmetic density just completely misses. And let's circle back to Egypt. When you look at it through this new lens, the picture changes, like completely. If you divide Egypt's population by only that fertile strip of land along the Nile, it suddenly has one of the highest physiological densities in the world. Now you can really see the incredible strain on the land that has to feed everyone.
But we can get even more specific. What if we wanted to understand not just the pressure on the land, but how efficiently that land is being used? Well, that brings us to our third and final lens, agricultural density.
Agricultural density zooms in even further. What it measures is the number of farmers for every unit of arable land. And this is a really fascinating metric because it's not just about how many people there are, it's a powerful clue about a country's technology and its economic development. So the formula is pretty straightforward. The number of farmers divided by the arable land area. A high number here means a lot of people are working the land by hand, while a low number suggests that machines are doing most of the heavy lifting. And this comparison makes it super clear. In developed countries, like the US, you see a low agricultural density. That's because technology allows just a few farmers to manage huge areas of land really efficiently. But in many developing countries, you see a high agricultural density, which usually points to a bigger reliance on manual labor and maybe subsistence farming. All right, let's put it all together now. We're going to take one country, our friend Egypt, and look at it through all three of these lenses, one after another, to see how the story builds. So let's watch this unfold. First, the arithmetic lens gives us this kind of misleading low number because it includes all that empty desert. Then the physiological lens comes in and corrects that, showing us the intense pressure on that little strip of land that has to feed everyone. And finally, the agricultural lens adds the last piece, revealing that lots of farmers are working that land, which suggests a system that's more about labor than advanced machines. So here's the real takeaway.
We're looking at the same country, the same people, the same land. But just by changing how we measure density, we get 3 completely different and way richer stories about what's actually happening there. And that really leaves us with a final question to think about. As our global population keeps growing and resources like land and water get scarcer, which one of these densities do you think is going to tell the most important story about our future? Is it the simple average, or is it the one that shows us the true pressure on our ability to survive? Something to chew on. Thanks for joining me.